Hello, everyone. Welcome to ZZ Classroom. I'm Mary, and in this episode, I'm going to teach you about one of the most important concepts in Algebra 2, which is transformation. So many of you probably already know about transformation before since you might learn it in Algebra 1, but in Algebra 2, you're really going to apply transformation to a lot of different types of graphs and really get deep into it. So it's pretty important, and I think it occurs throughout the whole Algebra 2 curriculum. So since it's very important, I'm going to divide this concept into several videos, and this is the first in this series. And I'm going to start with this basic expression here, which will give you a really good and basic understanding of transformation. So this expression actually express everything you need to know in transformation. Let's start with A. So the A here actually means all your vertical stretches and compressions. So my vertical stretch and compression can be expressed here using this A, which you will see the details later. And then B over here, it's your horizontal stretch and compression. So horizontal stretch as well as compression. And then the H here, you probably notice it's also like inside this parentheses, which is also a horizontal one, and it represents horizontal shift. And lastly, the K over here, it's the last one left, which is vertical shift. So many of you probably also think about reflection, which will occur later. It doesn't necessarily need to be in this expression, but I will talk about reflection too. So let's start with vertical ones first, because those are the ones that are less confusing and many people are really good at vertical transformations. So first, I'm gonna give you an example of vertical stretch. So vertical stretch by a factor, for example, by a factor of 3. So remember that if it's stretch, my factor gonna be greater than 1. So here 3 is greater than 1, so I'm good. So when I see vertical stretch by a factor of 3, I'm putting this 3 basically to this A over here. So I'm gonna say that my G of X is equal to 3f of X. So it's pretty easy right now because I don't have any other transformations and only have vertical stretch. So the only thing I need to do is replace this A with a 3, okay? And the second one I'm gonna do is vertical compression. So vertical compression by a factor of 1/3. This is 1/3 because for compression, my factor needs to be less than 1, okay? So when I do this, I'm still just replacing this A with the factor over here. So I'm just gonna do G of X equal to 1/3 of f of X. So basically that's vertical stretch and compression, which is really straightforward. You just plug this factor in as the A, okay? And then we're gonna do vertical shift. So vertical shift up 3 units. And you probably already know it's just gonna be G of X equal to f of X plus 3. This is also very straightforward. If it's up, you add 3, right? And then for the last one for vertical, I'm gonna have a vertical shift down 3 units. So if I'm gonna shift down, I'm gonna have a negative. So G of X equal to f of x minus 3. Okay, so those are my verticals. You would think they're very easy, but I would say that transformation, it's not easy. I mean, when I learn it, it's not easy. But right now for this vertical part and just standing alone, they seem pretty easy, right? And then next, let's do horizontal. So for horizontal, I'm gonna start for 5 here. Let's put this here. So I'm gonna have a horizontal stretch by a factor of 3. So it's a stretch, you need to have a factor that's greater than 1. So how am I gonna express this in this expression? So I'm gonna say that g of x is equal to f, and the inside here, I think you probably already noticed, over here, it says 1 over b instead of just b. So what I'm gonna do is that I'm gonna put this 1 over first over here. So 1 over, and you know that b is just a factor, which in this case is 3. So I'm gonna put 3 here and x. So basically my g of x equal to f of 1/3 x. So that's how you do horizontal stretch. Basically you're putting 1 over 3 inside here. So for example, if a factor of 7, I'm gonna put 1 over 7x here, okay? And then number 6, so it's gonna be horizontal compression by a factor of 1/3. So it's the same thing, but let's see. So g of x equal to f of, I'm gonna put this 1 over here, and I'm gonna put 1/3 and x. So many of y'all probably don't know how to calculate this over here, so I'm just gonna show you. So if I have 1 over 1/3, it basically means 1 divided by 1/3. So when you're dividing something, when you are dividing a fraction especially, you're actually multiplying the reciprocal of it. So for example, if I see 1 divided by 1/3, I'm actually doing 1 multiplied by 3 over 1. So it's gonna give me 3. So over here, I'm just gonna have f of 3x. So easy, right? So if, for example, if I factor 1/8, I'm just gonna put 8 inside here, okay? So that's for horizontal stretch and compression. And then next, number 7, I'm gonna have horizontal shift. So horizontal shift, I'm gonna put right first. Shift right 3 units. Right? So if I have horizontal shift 3 units right? Horizontal shift right 3 units, they're the same. Or by the way, for shift, you can also say translates. They're exactly the same. So for shift right 3 units, probably already noticed too, here I have a minus sign over here. So this 3 over here is gonna be my h value. So since I have negative in front of it, see how I'm gonna write it. So g of x is gonna equal to f of x minus 3. Right, so sometimes intuitively you would think that right there I'm gonna be plusing like plus 3, but in this case, when I add this negative sign, which is already in the expression over there, I need to put that negative sign here and then put a positive 3, which at the end I will have x minus 3. Okay, so last one, which is horizontal shift left 3 unit. Shift left 3 units. So what I'm gonna do here is that g of x is gonna equal to f of what? So f of x minus -3 here, right? So at the end, I'm gonna get f of x plus 3, but this plugging step, usually people ignore them. So that's why like sometimes left, people think it's going to be -3, but actually it's +3 because there is a negative sign originally in the expression. So that's why. And I think that concludes all of the 8 type of transformations related to vertical and horizontal. And the last two, I'm going to talk about reflection. So there are two reflections I need to talk about. The first one is reflection across the x-axis. So whenever I have a reflection across the x-axis, remember to put the reflection in front of f of x, which means I will have g of x equal to negative f of x, okay? And then lastly, for reflection across the y-axis, I'm gonna put my negative sign in front of the x. Though I'm crossing the y-axis, I'm going to put my negative sign in front of my x. So I'm gonna put g of x equal to f of negative x. So that's my reflection across the y-axis. And these 10 types of transformations really conclude all the transformations, like the basic transformations you will see in Algebra 2. And the next step, we're going to talk about how to have several transformations together and in different orders, how you're going to write the resulting equation, resulting function from the original function after those more complex transformations. And thank you so much for watching and hope you like the video.